With the world map, the Orbis Solaris sundial offers an extraordinary range of functions. The world map is based on a mnemonic map projection. Mnemonics is the science of sundials, but what does the mnemonic map projection have to do with sundials, and what is so special about the Orbis Solaris world map? Let's take a look at this, step by step. The first step is to look at the Earth. In this example, the horizon plane of Castle touches the globe at the uppermost point. We will now project the continents onto this plane using the mnemonic mapping. While Europe is still depicted quite naturally, the surrounding continents are strongly distorted as the distance from Castle increases. Let us now take a look at the special features of the mnemonic projection. We first draw Mecca, connect the two places with a straight line and slice the Earth along this straight line. An arc from Castle to Mecca is the air line, which is called an orthodrome in cartography. It always lies on a great circle around the centre of the Earth. In Islam, this is the direction of prayer to the Kaaba in Mecca, the Qibla. If we extend the straight line from the centre of the Earth into the map plane, Mecca is depicted there. Using the same method, we can project other points from the globe onto the map plane. The projection points take up ever greater distances from Castle and no longer reach the projection plane at an angle of 90 degrees. The projection point lies at infinity. We'll come back later to this special case, which, of course, also occurs at minus 90 degrees. First, let's bring the Sun into play. Twice a year, the Sun is at its zenith over Mecca, which is located in the tropics. The Sun's central ray hits the Earth's surface vertically at the so-called subsolar point and passes through the centre of the Earth as an extension. As expected, the sunbeam also passes through Mecca on the map as it follows the projection rule of the mnemonic image backwards. Now, all that is missing is the sundial, the namesake of the mnemonic projection. We set up a rod called a gnomon, standing vertically on the surface of the Earth in Castle. Following the shadow backwards is exactly the direction of prayer towards Mecca. The determination of the Qibla led to significant improvements in astronomy and celestial mechanics by the Arabs early on. It is important for us to realise that the plane of incidence of sunlight always intersects the Earth's surface in a great circle, and the map plane always in a straight line. Therefore, the mnemonic projection is predestined for the construction of the dial of a plane sundial. To show this, let's start again with Castle as the centre of the projection. Longitude and latitude are drawn here. The lines of latitude every 20 degrees, the lines of longitude every 15 degrees. 15 degrees is the angle by which the Sun moves around the Earth in 1 hour due to the Earth's rotation. When it crosses the meridian of Castle at solar noon, it is by definition 12 noon solar time in Castle. The hours of solar time in Castle are marked on the equator. Now we project the grid onto the map plane using the projection rule already shown. The extended Earth axis is the origin of the hour circles, which are shown as straight lines. In the case of the lines of latitude, only the equator is a great circle and becomes a straight line. The other circles of latitude are small circles and become hyperbolas and ellipses. In the next step, we project the parts of the Earth onto the map plane and draw the tropics of the Sun. From Castle's point of view, we now divide the Earth into an upper and a lower hemisphere. If we look vertically at Castle from above, we can only see the upper half. We have named the large circle that borders the hemispheres the solar event horizon. Seen from Castle, the Sun always moves above the solar event horizon throughout the year. When it is below this circle, it is invisible to the people of Castle. Let's take a look at the apparent movement of the Sun at the equinox. After sunrise, the Sun reaches the west coast of Africa at 12 noon solar time in Castle. The subsolar point is at the same geographical location in the mnemonic mapping. At 2 p.m. the Sun crosses the Atlantic. At 4 p.m. it reaches the northeast coast of South America, and 2 hours later, at sunset over the west coast of South America, the projection point no longer lies in the map plane, but disappears into infinity. The Sun also moves within the solar event horizon at the winter solstice and summer solstice. The projection point only reaches the map level around the middle of the day. We can now build a horizontal sundial from the mnemonic map projection. To do this, we first make the world map opaque and place it in the Sun. Due to the rotation of the Earth, the Sun moves around the Earth's axis every day. Consequently, we pull this out as a gnomon, but rotate the gnomon by 180 degrees so the shadow always falls on the side facing away from the Sun. In the meantime, the sundial shows 1:30 p.m. solar time in Castle. It is equinox, and the subsolar point shows us the position of the Sun over the Atlantic Ocean. If we use the vertical gnomon with which we have already determined the Qibla, we can read the same information from the shadow of the gnomon's tip. We have now learned how we can construct a horizontal sundial directly from the mnemonic map projection. However, it is impossible to transfer the solar event horizon from the globe to the dial, as it lies at infinity. But we can remedy this. To do so, we first replace the gnomon with a transparent body with a pinhole aperture. A flat incident sunbeam passing through the aperture will image it at a great distance. If we increase the optical density in the transparent body, the sunbeam is refracted as it enters and deflected inwards. Let us now look at the horizontal sundial from above and increase the refractive index n, the measure of the optical density of the transparent body. At n equals 1.491, the refractive index of acrylic glass, the event horizon shrinks from infinity to a dimension of 85 millimeters. This world map can now be integrated directly into the Orbis Solaris. As expected, it also shows 1:30 p.m. solar time in Castle. The Sun is just crossing the equator at the equinox. On an undistorted world map, the Orbis Solaris sundial always shows us where the Sun is moving over the world when the Sun is shining, all year round, from shortly after sunrise to shortly before sunset. With this unprecedented functionality and precision, the Orbis Solaris is unique among sundials. The Orbis Solaris sundial is available at helios-sundials.com.